Welcome to Hamden, Maine. I'd like to take you on a little tour of this bridge that's very unique. This is a project that started over a year ago, and it's on Route 1A, and that's the road from the coast to Bangor, Maine. And this project is unique in a way is that it's the last piece of a series of construction projects that connect the coast with Bangor. And so what I'd like to do is just take you on a little tour and talk about some of the unique features of this bridge, and especially the use of composite technology and also the sustainability of composites, and you can see how it fits well with the site. So before we begin the tour, I'd like to talk a little bit about the highway portion of this project. And as you can see, the sidewalks that are very pedestrian friendly. This actually is a good connection between Hamden, Maine and Bangor, Maine. Folks can now walk completely all the way through without going in the road. It's very pedestrian friendly and bicycle friendly. And as you can see, there's quite a lot of traffic on this piece of road. The reason that this piece of road was sort of the last connecting piece was primarily because of the bridge. The bridge was a very expensive undertaking. The existing bridge that was here prior to this was very narrow, no sidewalks, and over the years had reached the end of its life, and it was time to be replaced, but it was a significant project to do that. And so I want to take you on a little tour and show you that. First of all, we're going to walk down the embankment here, and we're going to look underneath the bridge. This is a very interesting, very environmentally sensitive waterway that we're going to see. And we even see some fishermen on the other side of the bridge, eel fishermen. This also is a salmon stream as well. All the construction had to be done around the migration season for the fisheries, and also a lot of environmental protections as far as keeping the stream as pristine as possible. You can see the complexity of this bridge is interesting because it's geometry-wise, it's a sag curve bridge. The highway is a sag curve. It's also part of a horizontal curve, and it's super elevated as well. You can see several utilities underneath. It's the main connection for the water lines between both here and Bangor, and plus there's other utilities, a telephone and other things that run through this. There's 2 sewer lines and a water line. You can see the main feature here, and what we wanted to point out, what makes this bridge so unique is the use of composite technology. And if you look at the side of the bridge, it looks traditional, looks like concrete, but however, it's very lightweight. It's made from sustainable materials. From an engineering standpoint, with any technology, when you do something that's unique and different, there's a lot of interest. We're getting interest from around the world.
The purpose of the CT girder design was to really reinvent the way we use composites. The goal was to learn from everything we've done over the last many decades in composites and come up with the next big thing. The whole design effort was, how do I make it lighter? How do I make it easier to ship? How do I make it faster to erect? There's been a lot of other very good designs out there. And what we try to do is learn from decades of work to develop this new technology right here. And it is very unique. There's really, as far as I know, nothing like it in the composite world. Using less materials to build the bridge, it's lighter. You don't need the heavy cranes to mobilize them. You don't need to pay for them. You don't need to have the CO2 coming out in the air to get them to the site. So it has a much smaller environmental footprint than other bridges. And the fact that it lasts longer, the fact that you can have 2 lifetimes out of it versus a single lifetime. Instead of building 2 bridges, you're building 1 bridge. And you've cut your environmental footprint significantly.
It is necessary that as a matter of public policy, we review and analyze the opportunity to use more sustainable materials, not only in our bridge building, but in other structures. For the small and medium bridge market particularly, the use of composites needs to become a standard.
I love new products. I've gained a lot of faith in composites and this type of technology over the last year and a half of watching this system done. My experience with this technology really started when the first girders were tested 2.5 years ago now. That was a great experience to watch that get tested to the Strength 1 design requirements. There's really no guesswork. We know what the materials in these girders are. We know how strong they are.
Sustainability and infrastructure is becoming a policy prerequisite. This technology is made of composite material, no steel reinforcement, and will not corrode. If you can build a bridge that'll last over 100 years, and you can do that in a competitive, price-effective manner, it makes economic sense, it makes environmental sense, it makes operational sense.
That's remains of the existing bridge over there. The abutments and foundations were a challenge because, as you can imagine, an older bridge with multiple renovations to the older bridge, there was a lot that had to be removed. The new bridge is wider. The span is longer than the existing bridge, than the bridge that was here, and primarily that was to allow some riverbank that wasn't here before. And that will provide more access to people that want to come down and fish, as well as just come down and enjoy the stream. It's going to last well over 100 years. It's durable. This is actually brackish water, so you've got some environmental concerns. You're in Maine, it's winter. We use de-icing materials on the bridge. And this is all non-corrosive. There's nothing in this bridge that is going to, over time, deteriorate from the environment. You know, even the deck has non-corrosive reinforcement in it as well. So this was an ideal site for the first composite G-beam bridge, and it was for a number of reasons. Is that when we began looking at possibilities for siting the first one, we realized that the tests at the University of Maine that were done with a 40-foot span, and we wanted to take it to the next level. And this was ideal because it gives us an opportunity for a 75-foot span bridge, and it also gives us an opportunity to not only the composite girders, but also do it in a traditional cast-in-place deck on the top. And the work that was done at the University of Maine was based on precast concrete and the connections involved in using precast planks or longitudinal precast, as opposed to doing a traditional cast in place where you would use traditional construction techniques. One of the things that was really fortunate for us is we had a contractor that was open to innovation, and you know, there are, you know, obviously a lot of firsts with this bridge. The fact that you're doing it, you know, the form work is going to be a little bit different. You know, one of the things here that you see is these utilities that are below the bridge. That was one of the first things that was discussed during the design phase, is how do you attach the utilities? And it's not that much different than working with traditional materials. You know, you can put connections on this material, you can bolt it together, you can do a lot of different things and provide a structure that is easy to assemble. And from the contractor's perspective, the assembly of this and erecting these girders was really helpful in terms of the construction project. It allowed it to proceed very quickly. You know, in other places where there's a real time constraint to get structures in place, composites are the ideal solution because they can be assembled very quickly, put in place, and with the precast option, you can have the bridge open to traffic very quickly.
We like innovative stuff. We've seen some composite girders, but they were all filled with concrete. The weight's always a factor. The speed in which we can move them around and manipulate them, spin them, hold them is very simple because of the weight.
You can put two girders together, install the utilities, and lower them all into place at the same time. You don't need heavy equipment, and it goes in a day and a half.
More of the contractors can bid with their means and methods. They don't need necessarily the giant crane that, 3 or 4 companies have, which always means you allow more people to compete for the project, and that lowers the bid prices. There isn't any DOT that would tell you that they have enough money. If there's one, I'd love to meet them. If we can find products that give us another 25 years of life in a bridge, that is real money you don't have to spend into the future.
Contractors spend a lot of time not only in figuring out how to put a bridge together, but also how to put it together safely and to keep their employees safe. The fact that these things go together fast and easy reduces the risk to the contractor. Grist Mill project is our first using the composite girder. You want to build structures that are going to be long-lasting. If you use a composite type of reinforcing GFRP, then you eliminate all the issues that go with corroding steel. You don't have to go out there and do maintenance. For instance, if you compared it to a steel structure, you have to go out there and take care of corrosion. So you have to repaint it. And what are they using today out in California to strengthen concrete for earthquake, for seismic? They wrap it in composites. So if you're using it for repair, why can't you use it initially to build? So we've talked a lot about this tour on this being the first use of the G-beam technology and the composite technology in providing replacements for the bridges around the country. As of today, we have projects that are planned and going forward in multiple states across the nation. This technology is really beginning to accelerate and take off, and primarily because of the use of this material has been used in a lot of other industries. It's been used in automobiles, it's been used in aerospace, and now it's finally reaching infrastructure. And you hear a lot in the media about how bad the infrastructure is in the country, and the need to, when we replace it, to replace the infrastructure smartly with new materials that will last a lot longer, so that our children and grandchildren will not be faced with the infrastructure crisis that we have today.
It feels good to make some history. We are a believer in this product. Our bridge engineers asked to use this. There's a sustainableness about this girder, not as energy intense as other products. People are going to start to really think about sustainable products. There's a lot of studies going on right now about construction emissions, and I think you're going to see that they're higher than we all thought. Part of our obligation as departments of transportation is to really extend the life of our bridges moving forward, and using materials that may be innovative or new and seeing what they do for us.
The public's demand for more sustainable practices and technology is growing rapidly. The girder is the standard operating equipment for building most small to medium-sized bridges. From the standpoint of a policy objective, particularly in the climate change, sustainability arena, this technology is going to be in demand in the future.
For the engineers that I know are in the audience, you're going to ask about what is the characteristics of this G-beam in terms of mechanical properties, and why is this useful to bridge engineers. And as a company, we're bridge engineers that use composites, and that's a little bit different in the industry. And so we look for the best in all the materials that we use, that we put into our designs that end up as projects. And so one of the things I wanted to talk about was the strength. The girders are, their primary constituents are glass and carbon fiber. And one of the things that I wanted to say about the design is that you have to meet AASHTO requirements. And we can very easily do that with our designs, with the G-beam, and primarily because we use carbon, and we use carbon where it's best used, which is in the tension, the bottom flange of the girder, and we use glass for the webs and for the top flange. We have some unique things that we do as far as the connection between the girder and the concrete deck, using shear connectors. There's a lot of innovation that goes with that. The materials themselves, deflection-wise, are not that much different than designing with steel and concrete. This particular bridge, because it was the first using this technology, as engineers, we want to be very, very conservative with our design. The L over D deflection is well over 1200. So, the requirement for pedestrians, and so there's very little movement. When we did the load testing on this bridge, putting well over 200,000 pounds in vehicles on the bridge and positioning them for the maximum moment, we had less than a half an inch deflection, and as engineers, that's pretty darn good for a structure. As you can see, part of the heavy traffic and the heavy truck traffic that's on this bridge, it's going to withstand the test of time. The critical connections have been fatigued to 6 million cycles, and so they're well within the code limits, but even more than that. As we continue to do these bridges around the country, we'll continue to show that these materials are strong, they're durable, and they're corrosion resistant. And given the lightweight, one of the other benefits of the material is when you think about alternative materials and the weight of alternative materials, you're using a lot of the structural strength of those materials just to hold the structure up, the dead load of the structure. With FRP, you're really optimizing your materials, the modulus, so that you control the deflections, and it acts just like other materials, only different mechanical properties that are superior to some of the other materials. The next thing I'd like to just mention is that today is a very special day because we're doing the ribbon cutting on the bridge. This is being done by the University of Maine and Advanced Infrastructure Technologies. And we've got a lot of VIPs coming today to take a look at the bridge and to see the new technology that's being employed in this structure.
Today is a true celebration of a milestone in advanced construction technology. The Grist Mill Bridge is the first in the nation to use sustainable composite girders designed to last 100 years. That's an accomplishment that deserves applause to all of you involved. So this is a great day, and I want to congratulate Habib Dagher and his team at the University of Maine, AIT, which was involved in the design and building of the bridge, Commissioner Van Note from the State Department of Transportation, the Army Corps of Engineers. This shows what we can do in partnership when we all work together. We have had 2 hearings in the Transportation Appropriations Subcommittee, and in both of those hearings we focused on how can we make our roads and our bridges and our highways more resilient, greener, last longer. This is an exciting day to see material and research developed in a lab translated into an actual bridge. 3, 2, 1. Ta-da!
What I wanted to leave people with is this is a section of the girder, and it shows the inside of the girder. There's no concrete filling the girder. Concrete deck does go on top here and is connected to the girder. And this is very unique in the industry. It's so lightweight, as you can see. It's very lightweight compared to normal steel and concrete. And it's very strong, durable, and will last well over 100 years. So the other big advantage is that it's environmentally sustainable. And we spent a lot of time in research and development, and this is kind of the culmination to do this first bridge using the G-beam. We're looking forward to doing many more around the country and around the world.